A quote from Professor Adam Riess highlights that our understanding of the universe was completely wrong. Nobel Prize winner Adam Riess warns of a strange discovery made by the James Webb telescope: the universe is expanding in ways we no longer comprehend. Webb reveals galaxies that are so peculiar they seem impossible. While some see this as a failure for researchers like Adam Riess, it marks the beginning of a new science offering long overdue answers to fundamental questions about the universe. Riess understands that the expansion of the universe and Webb's extraordinary observational data are linked, and the entire crisis may stem from one tiny detail we've overlooked. Even the old Hubble Space Telescope captured a strange image of a complex galaxy that is unusually old. This galaxy, called GZ9P3, was merely a blur of light for a long time with little detail discernible until Webb came along. The new telescope not only confirmed the existence of this galaxy but also revealed its unusual age, existing only 510 million years after the Big Bang, making it a galaxy in the early stages of the universe, which is believed to have begun 13.8 billion years ago. GZ9P3 has since been thoroughly investigated by the International GLASS project, revealing more inconsistencies. GLASS stands for Gravitational Lensing Amplified Survey from Space, and this project searches for the light of the oldest galaxies. The results showed that GZ9P3 was not only advanced for its age but likely resulted from a merger between two or more smaller galaxies. This discovery, like the existence of the galaxy itself, is a scientific miracle. While galaxies may theoretically have existed 510 million years after the Big Bang, they are unlikely to be as developed and large as GZ9P3. The fact that galaxies merged at such an early point in the universe challenges our previous theories of galaxy evolution. The new study by the JWST also indicates that GZ9P3 has a double nucleus, suggesting that the merging of galaxies could still be ongoing at the time the image was captured. The GLASS team found that GZ9P3, like other early galaxies observed by the JWST, is already massive and mature, which is unusual for a galaxy in the young universe. Many researchers are now discussing the term impossible, though we must be cautious. These galaxies clearly exist and are not impossible but rather defy our current scientific explanations. It's remarkable that these galaxies contain billions of stars at such an early epoch, yet we are in the era of the end of the Dark Ages, meaning only the first stars should be visible. The James Webb was designed to show us these early stars, but instead we see impressive and highly developed galaxies that appear several billion years old. How can these galaxies exist? Many are unaware that Hubble had previously discovered very old galaxies that didn't fit the established narrative. At that time, galaxies existing 500 or 400 million years after the Big Bang were seen as exotic cases. Additionally, it was unclear whether the light spots were indeed complex galaxies. Hubble's images lacked the clarity of those from the JWST. Bright luminous objects in the early universe could also have been clusters of the so-called population 3 stars, believed to be the first stars significantly larger than those we see today, and composed mainly of light elements. These stellar giants had luminosities that would make today's stars appear dim but burned out within a few 100,000 or million years. Now Webb's analysis reveals millions or billions of stars within these blurry patches of light, contradicting the old assumptions of a few giant stars clumping together to form proto-galaxies. Many of the galaxies examined by Webb show complex structures such as spiral arms and bars, indicating a more advanced developmental stage than previously thought. GZ9P3 remains a mystery among the ancient galaxies discovered so far, as it is not only more massive than expected but about 10 times more massive than other galaxies Webb has observed in a similar epoch. Its complex shape with two bright spots revealing dense cores suggests it probably formed from the collision of two early galaxies. In Webb's detailed images, a large number of young bright stars were visible within GZ9P3, likely formed by the galaxy merger and under a few million years old. Within the galaxy, however, Webb also identified an older stellar population over 100 million years old. The GLASS scientists utilized Webb's advanced spectrometer to uncover this fascinating information about the extremely distant galaxy. Observing details of a galaxy more than 13 billion light-years away represents a significant achievement for cosmologists. With Webb spectroscopy, researchers can determine the elements that compose these stars, as younger and older stars exhibit different compositions. The researchers successfully differentiated the two categories within this early galaxy, with older stars appearing redder and richer in heavy elements often referred to as metals. When older stars exhaust their hydrogen supply by fusing it into helium, they produce even heavier elements. In contrast, younger stars are still dominated by hydrogen and some helium, making them distinctly different from the older stellar populations. GZ9p3 is rich in silicon, carbon, and iron, the heaviest element that can be synthesized by stars. This indicates that when these stars died in supernova explosions, they enriched the early universe with metals which later became the building blocks for the next generation of stars, galaxies, Earth, and ultimately ourselves. Adam Riess points out that we have misunderstood the universe. It's fascinating that the James Webb Space Telescope confronts us with so many new facts that force us to completely rethink cosmology. Adam Riess, a Nobel Prize winner and researcher at Johns Hopkins University, has been investigating the so-called Hubble tension for quite some time. He realized before Webb's launch that we likely had a significant error in our understanding of the universe. Riess is among the leading scientists studying the Hubble constant, which indicates the rate at which the universe expands. Scientists have relied on this constant to determine distances, expansion speeds, and even the universe's age. Riess and his team have examined the discrepancies in the measured values for the expansion rate which occur when measurements are taken from different fixed points. Measuring the universe and its dynamics is challenging because all objects are in constant motion and we lack fixed reference points in space. Consequently, scientists base their measurements on objects and events deemed most constant, typically those that emit significant light, which is considered the most reliable quantity in the universe. However, light is also in motion. Another source is cosmic background radiation, which resembles an imprint of the universe's earliest events. Measurements based on cosmic background radiation suggest an expansion rate of about 67 km per second per megaparsec, while data from Cepheid stars indicate a rate of about 73 km per second per megaparsec. Adam Riess and his team refined their work thanks to the Webb telescope and aimed to ascertain whether a potential measurement error from the Hubble Space Telescope could be the cause of the discrepancies. However, Webb corroborated the same deviations, raising concerns. Somewhere between these two observations, there must be a fundamental flaw in our understanding of the universe, Riess said in an interview with an astronomical journal. The use of the new space telescope has allowed for deeper insights into the universe through its sharp infrared view and more precise studies of cosmic distances. With Hubble and Webb confirming significant deviations, there's strong evidence of an error in our theories. For Riess and his team, this represents progress. If measurement errors can be ruled out, we must explore our other conceptual frameworks to uncover the hidden errors that could explain these strange observations. Since Webb became operational, discoveries incompatible with old theories have been accumulating. Adam Riess awarded the Nobel Prize in Physics in 2011 for discovering the accelerated expansion of the universe, views these findings as an opportunity to advance science. If our previous measurements of the universe are inaccurate, the determinations of its age, the concept of expansion, and even the idea of the Big Bang could be wrong, or at least not entirely correct. The universe may be much older than previously thought, and these discoveries may have implications for our understanding of the origin of matter. Unexpectedly massive and highly evolved galaxies indicate that the universe 13 billion years ago and beyond was not as we previously envisioned. This leads to new perspectives on the universe. What do you think when a scientist like Riess claims that our understanding of the universe is probably completely wrong? Could it be an infinite universe, the dimensions of string theory, or the possibility of millions of universes, as suggested by quantum physics? Scientists are currently hesitant to embrace such radical theories based on new observations, instead believing that the discrepancies in the Hubble constant might stem from misunderstandings or misinterpretations of dark energy. This mysterious force, understood to be driving the universe's accelerated expansion, remains largely unknown regarding its properties and behavior. It's possible that dark energy is unevenly distributed throughout the universe, or that its effects change over time and space, leading to the differing measured expansion rates. Another line of thought involves dark matter, another crucial component of our ancient cosmology. Yet we have never conclusively proven its existence or true properties. Perhaps we overestimate its uniformity and underestimate the complexity of its distribution in the universe. Irregularities in dark matter's distribution could influence cosmic structures and the observed expansion rates, mirroring the current experiences we face.